My name is Jeremy Tyler, and these are my colleagues Pascal Brissette, Murat Bronze, and Michel Barras. We are Team ENAC from Civil Aviation University in Toulouse, France. Our aircraft was designed entirely in CAD and manufactured entirely by CNC. We have a very sophisticated design using our own proprietary airfoil and our own open source autopilot. The weight is 247 grams, speed is 12 to 15 meters per second in cruise, and we flew almost 35 minutes yesterday during the demonstration. We have a 2-axis gimbaled camera that is able to follow a fixed point on the ground or follow a moving track independently or dependently on the path of the plane. We chose a very pragmatic approach. We decided to focus only on the aircraft, on developing a high-performance, reliable aircraft, and unfortunately we did not spend any effort in other technologies that were being sought in this competition, such as chemical detection, UGVs, vision algorithms, and so when the weather cut our competition schedule short, the judges asked us, told us that we would not be able to participate. We were given an opportunity to do the mission, to do a brief demonstration after the competition had ended, and so we chose to do the mission just for fun. Our mission strategy had been developed ahead of time, of course, as we were prepared to do the competition, and the strategy was as followed: to launch the aircraft, the first aircraft, very quickly, and survey as much of the route as possible on a carefully planned path to the bank complex, identify the red team guards as soon as possible, and identify their timing and monitor their timing throughout the mission while we pan and observe the entire field for obstacles and monitor the progress of our UGV and commandos throughout the mission. Turns out the strategy worked very well. We did exactly that, and we got further than any other team did. We made our commando and our UGV, made it all the way to the last point without being detected, and we identified one mine and 3 obstacles. The obstacles were all identified by the aircraft ahead of time. The mine was identified by the UGV, and we also identified that the hostages were not on the south side of the building. We ran out of time for checking the east and west sides of the building by air, and as our mission was cut short at 30 minutes. But we returned to base and had a perfect autonomous landing right at the launch point. I believe we were the only team also to not crash. Though we weren't able to succeed in this mission, we have had many other successes that we are very proud of, starting with one of the very first autonomous MAV competitions in 2003, which we won first place with Pascal Brissette, and also in 2004 with Braunschweig. Pascal Brissette again won. He won 2 in 2004 actually, once in Toulouse as well. In 2005, I won first place using this plane up here on the poster. In 2006, there were 4 teams, and all of us were using paparazzi systems, and of course we got 1st through 4th places. In Florida, we won 2nd and 3rd place, beat only by BYU University. And in Toulouse in 2007, 1st place, and 2008, we were proud to have 4 out of 12 teams are using the autopilot that we developed. And 3 of the 4 teams that were able to fly successfully and productively during the mission were using our autopilot. And we're very proud of that, and we owe many thanks to Martin Mueller for his contributions to the Paparazzi project and his contributions and assistance with our team. And if we have moments for questions, I know we have a little bit of time left, I think, if anyone has any questions. Okay.
Yes, we've got about 4 minutes left. We either have questions or we can help the schedule out, which is behind. Okay, well, thank you very much. Go ahead.
Any quick details about the plane itself?
In what sense?
Construction, propulsion.
Construction is all Kevlar and with a styrofoam core, and it's all done on CNC milled molds. And propulsion is a brushless outrunner. It's mounted internally for dust and water protection. I don't know what else I can tell you. We have a modular payload system. This is our pan-tilt camera system here, and this entire plate is replaceable with a fixed camera or a different payload, a chemical sensor, or any other payload we could develop to fit in here. All of our antennas and control mechanisms are all internal. There's nothing exposed to be damaged. The structure is extremely strong, and it's built to withstand thousands of flights and thousands of autonomous landings. And I think that's about it.